This is lesson 4.1, and we're talking about classifying triangles in this lesson. So a lot of review of names that you have heard before. So triangles can be classified by both their angles and their sides, So we have acute when all three angles are acute. We have equiangular when all these angles are equal, and we know those are going to all be 60. We're going to learn that. And then obtuse when we have at least one obtuse angle between 90 and 180. And then one right angle is called a right triangle. If we classify by their sides, those are equilateral. So this one up here had angle kind of in its equiangular. This one has equilateral for the sides being all equal. Isosceles, two sides at least that are congruent. So an equilateral is actually also an isosceles. Scalene, they're all different. None of them are congruent. So let's take a look at this one down here. Opposite of our capital A, angle A, is side A. So the side opposite angle A is side A. So these would be opposite. Adjacent would be kind of your next to. So we have two legs on a right triangle, and we have the hypotenuse here. And then each point is a vertex. So let's go ahead and practice classifying here. We are going to classify it as acute, equiangular, obtuse, or right. So this one, they're all small, so it would be an acute. This one, oh, I see a 90, and 90 is right, or if you see that box in there, so that would be a right triangle. The next one, 97, that would be classified as obtuse. And then this one, they're all 60, so they're all equal. They're equiangular, because we're talking about the angles. Angular. And then this one, it looks like we are, I think, classifying the overarching, the big one, not the smaller ones in here. So together, that is going to add up to 104, it looks like, so that would be obtuse. On this next one here, let's go ahead and have you try. So BDC. So it looks like we have a 100-degree angle right here. So if it's 100, what would that be? Hopefully you put obtuse. And then our next one is going to be a BD, this one right here, which is 80, 20, and then that would have to be 80 as well. So 80, 20, and 80 would be acute. All right, if you want to practice this one, putting by side lengths, so your options for that one should be equilateral, isosceles, or scalene. So go ahead and try A, B, and C, and check when you're ready. And double check that you got isosceles for A, for your EHF triangle, because we have two tick marks here showing these two sides, at least two of them are congruent, so isosceles. Then EHG, kind of the big one here, looks like you have sides 12, 11, and then 14, so they're all different, so scalene. And then HG and F, HFG, this one right here. So this is 10, this is 4, and this is 11. They're all different, so again, scalene. All right, for this next one, if M is the midpoint of JL there, then that would put us at 0.75 here, 0.75 there. So all those tick marks mean 0.75 all the way around there, it looks like. So MLK, this triangle right here has two markings, so we should have isosceles. So we're classifying it by sides, which we have our options there if you need spelling. The next one, JKM. JKM is going to be this one right here where it has all the tick marks on each side, which means it should be equilateral. They're all the same. And then our last one here, it looks like we want K, J, L, the big one. So we have a 0.75, we have a 1.3, and we have a 1.5. They're all different, so scalene. All right, this one gives us the perimeter, and then it gives us all the sides in our picture here. We want to find x. So we need to add all these up. So 2x plus 6 plus 3x plus 8 plus x plus 3. Adding all those up, setting it equal to 47, because a perimeter means all the way around. It's total. So 2, 3, and 1 is going to make 6 x's. 6, 8, and 3 is going to make 17. And now we can go ahead and solve. Subtract 17 from 47. 6x is equal to 30. And when we divide by 6, we get x is 5. So with x being 5, we're going to plug that back in to each of these equations. So DE is our 2 times 5 plus 6. And 2 times 5 is 10. 10 plus 6 is 16. And then we're going to plug it into our next one, which is DF here. X plus 3, 5 plus 3 is 8. And then the last one is going to be 3 times 5 plus 8, and that's 15 plus 8, which is going to give me 23. All right, so our last example here, what we're going to do is we're going to find the side lengths, the measures of the sides, and then we'll be able to classify it, but we need to know what those lengths are. So there's two ways that we can do it. We can do distance formula, knowing this point and this point, and kind of use our x2 minus x1 squared plus y2 minus y1 squared. But the easier way for me to kind of do it is to do Pythagorean theorem. So basically, I'm going to turn this into a triangle, and I'm going to find the hypotenuse. So I just need to know this leg and this leg. Well, this leg right here is easy to count. It's just 1. This one is 1, 2, 3, 4, 5. So I'm going to take, and I'm going to do leg squared plus leg squared, and then I'm going to do the square root of that sum. So square root, what's this leg? 1 squared. This leg plus 5 squared. And 1 squared I know is 1, 5 squared is 25, and then I'm going to square root that sum. I'm just going to leave it under the radical because that's not going to be very pretty. All right, let's do it again. This time for PL, so P to L, straight down, straight across, 1, 2, 3, 4 for this leg, 1, 2, 3, 4 for this leg. So I'm going to take 4 squared plus 4 squared and do the square root. So 4 squared, 16, and 16, and that total is 32. All right, try that last one, KL, on your own. Find your two legs, square those legs. So 25 and 1 makes 26, which, hey, we have a 26 right here. So that means that this side and this side are the same. So what kind of triangle is it if two of the sides are the same? Isosceles. And you are done.